Preparation of diphenyl methane. As a large amount of hydrochloric acid is formed in the preparation, the apparatus should be set up under a hood in a 1500 flask provided with a reflux condenser. Place 120 grams of benzene and the aluminium mercury couple, which is prepared as follows. Cut up 2 grams of aluminium foil into strips about 1 inch by 0.5 inch and allow them to stay in a solution of mercury chloride made by dissolving 1 gram of the salt in 200 centiliters of water for 8 to 10 minutes. A film of mercury is deposited on the aluminium. Wash the couple thoroughly with water, then with alcohol, ether, and finally with benzene. Into the upper end of the condenser place a separate funnel containing 16 grams of benzyl chloride. Allow the chloride to drop very slowly into the flask. At the end of an hour, heat the flask on water bath for about 15 minutes. Pour the contents of the flask into an equal volume of water, which contains a little sodium hydroxide. Shake, separate the benzene solution, and extract the aqueous layer once with a little benzene. Combine the benzene solutions and dry them with calcium chloride. Pour out the solution into a distilling flask and distill using a condenser until the temperature of the flask of the vapor reaches 115 degrees. Remove the condenser, attach a short air condenser, distill and collect the fraction with boils at 215 degrees, 300 degree. Redistill and collect the portion boiling at 255 degree, 265 degree. Record the weight obtained and calculate the percentage yield from the benzyl chloride. The yield should be about 35 grams. Diphenil methane melts at 26 degree and boils at 26 degree. In the preparation of certain compounds by condensation as a result of the elimination of chlorine and hydrogen, aluminium mercury couple gives better results than aluminium chloride. It is possible that little aluminium chloride is first formed by the action of the metal on the organic halogen compound. The presence of mercury makes the aluminium more active. Oxidation of diphenyl methane to benzophenone. In the identification of organic substances, they are frequently oxidized and the product isolated. The following procedure is an example of one commonly used. Dissolve 5 grams of diphenyl methane in 10 centiliters of glacial acetic acid and add a solution of crystalline chromic anhydride prepared by dissolving 4.5 grams of the anhydride in 5 centiliters of water and adding 13 centiliters of glacial acetic acid. Let the mixture stand for half an hour and then warm for an hour on the steam bath. Pour the product into 100 centiliters of water, filter off the oil throughout a moist filter paper, dissolve it in 20 centiliters of hot alcohol and add cold water until the solution clouds. Set aside to crystallize. If an oil separates, rub it against the side of the beaker with a glass rod, a form of benzophenone which crystallizes with difficulty is produced as a result of the oxidation of diphenyl methane. If a sample of benzophenone is available, trace can be used to see the oil if it has not crystallized when rubbed sharply against the beaker. Determine the melting point of the crystals. Benzophenone melts at 1480 degree. In oxidizing compounds with chromic anhydride, a slight excess is used that's required for the oxidation. 2 molecules of the anhydride furnish 3 atoms of oxygen. If the compound, which is insoluble in water, is to be oxidized, acetic acid is often used as a solvent, as chromic anhydride is difficulty soluble in glacial acetic acid. It is first dissolved in a little water and acetic acid acid added to the solution. Oxidation takes place more readily in the presence of a small amount of sulfuric acid, which is often used as a catalytic agent. Formation of hexaphenyl ethane. In a test tube, put about 20 centiliters of ethyl acetate or ether, 1 gram of 3-phenylchloromethane, and 5 grams of final granulated zinc. Close the tube with a tightly fitting cork and shake frequently during 10 minutes. Dissolve little iodine in ethyl acetate. Filter off the solution from the zinc rapidly throughout. Apply the filter paper into 2 test tubes. To one, add the iodine solution drop by drop. Shake the other solution in contact with air. Set the tube aside and examine it in a few minutes. Properties of naphthalene. Solubility of naphthalene. Test the solubility of naphthalene in hot and in cold water, alcohol and ether. Naphthalene and bromine. Add bromine drop by drop to a few crystals of naphthalene. Compare the ease of substitution in the case of this hydrocarbon with that of benzene. Compound of naphthalene and picric acid. Picric acid stains the hands. It should be handled carefully. Dissolve 0.1 gram of the hydrocarbon and 0.2 gram of picric and in 5 centiliters of boiling alcohol. Allow the solution to cool spontaneously and collect the yellow needles of a filter by suction and wash them 3 times with a cold alcohol using 1 centiliter of alcohol each time. Dry the crystals on a porous tile for half an hour in the air and then determine the melting point. The compound of naphthalene and picric acid has a formula as follows: C10H8 coordinated with C6H2 and O2 molecules OH. It melts at 105.5 degrees. Note that naphthalene and bromine react readily without the presence of a halogen carrier. The reaction can be used to prepare anhydrous hydrogen bromide. Picric acid, which is trinitrophenol, forms crystalline addition products with a number of organic compounds that are frequently made as an aid in the identification of certain hydrocarbons.